Okay, good morning, guys. So let's start today's session with same topic. Let's Huffman coding. In the last lecture, we have discussed Huffman coding. So, which are the types or how it will work? Let's see overview, and then I want to give a few example on that. So, let me share my screen. So Huffman coding, normally there are two methods. First one is a fixed length coding, and then second that's a variable length. Fixed length coding, you just simply make the combinations of bits as per the given characters, and then we send the bits. For example, let me write here one example and just give me the answer for both the methods, as well as variable length. So what we done in a fixed length, for example, number of distinct character here is the 5, then we require the 3 bits to represent these 5 characters. Okay, and then we send the complete message 3 bits as per the given input message. Also we will send this table also. So this total number of bits for the fixed length. So let's give me the answer. For example, I'm just sending the message here that's so here, how much characters? That's let's 3, 3, 6, 5, 10, 15, and let's write another one. Okay, that's this one. Total 20 characters. 5, 5, 5, 5. Okay. So now, just give me the answer. How many bits you have to send in a fixed length of main coding? So just give me the answer. How many bits you have to send this 20 character message with fixed length Huffman coding? How many bits? For your reference, that will be the PPT example, and then try to solve this example. So once you solve the answer or solve the problem, then drop message in chat box. Anyone, what is the answer? Guys, see again, what's here? How many bits? Okay. Here, distinct number of characters that's required here are 3 characters, ABC. So for the ABC, we require only 2 bits to represent these 3 characters. For example, 00, then you may write here capital A. Sorry. How we can write? Let me write in notepad. So you require the two bits for each and every characters. There are 3 characters, so we require only 2 bits combinations. Something like 00, that's for the capital A, 01, that's capital B, 10, that's capital C. Okay, let's see. 00 capital A, 01 capital B, and 10, that's capital C. Or if it is one more letter, then you may write D also, something like. But here it's only 3 characters. So we require the 6 bits total and 2 bits for represent each and every characters for our message. So let's send this complete message. Then we require here 2 bits, something like here 00, then B, 01, C, 10, again BB. So that's 5 characters. Then again 00, 01, 10, 00, 00. Then this one, and so on. So here it's total. You are sending that's 20 into 2 is equal to 40 bits. That's for the message. For the decoding at the receiver end, we have to send also this table, something like for the table 6 bits plus 3 characters. That means it's require 6 bits plus 3 into 8 bits. So total here 6 plus 24 is equal to 30 bits for table. And finally total 40 plus 30 is equal to 70 bits sent. So this is the fixed length of main coding. Fixed length in the sense number of bits is fixed for each and every characters. Clear? Is there any query in this method? Any doubt? Guys, please reply. All of you clear? How we calculate here 70 bits? Okay, that's one. Now next one, that's the most important for your exam, that's a variable length. So let's see first of all a reference example and then we calculate the message for the same example. So what is a variable length? So variable length, you have to first simply count the frequency, this one, and implement this table. After writing this frequency, arrange in ascending or you may say that increasing order, then make the tree, take 2 elements with the least cost, and minimum count in the left side, greater count in the right side. Just complete the tree. Then travels or write the 0 for the left child and 1 for the right child. 0 for the left child, 1 for the right child. So we'll get the Huffman coding for this one. For example, if you want to send letter capital A, then you have to send here 01. For capital E, 00. For capital D, that's something like 100. So this is the table, or you may say that here it's a variable length. Yeah, and for that also you have to send number of bits, calculate length of the message. Or number of bits is equal to 4 into 2, 7 into 2. So here it's a frequency 4 for the capital letter A. For that you are sending 2 bits and similar kind of that one. And again it's 52 bits, that's for the table. That's for the table. Okay, so total here it's a 97. So let's follow the steps. Variable length. So first of all, you have to create the heap tree, mean heap. Or you may say that it's a summation. So let's call the max heap. So now, for the same message, but variable length. So first of all, just simply create the tree. Okay, before that, make the table, that's a frequency table, and then create the tree and then find out the total number of bits. So try yourself and then okay, try yourself and then I will give the answer. Okay, this is our message. So done, it is frequency table, it's very easy, only 3 characters. So how many times here? 1, 2, 3, 4, 5 and 6. So just I am writing here character and frequency. How much calculated? 6, no? Yeah. Then capital B, 1, 2, 3, 4, 5, 5 plus 3, 8. Capital C, that's a 1, 2, 5, 5 and again 6. Okay. Now just simply write in ascending order and make the tree. So first of all, you will get the tree. That's how we write something like this one. This is the tree, if I'm not wrong. And when you write the coding for this one, so you will get here answer for the capital A. That's 10. Capital B 0 only. Capital C 1. If I'm not wrong. Now just simply calculate the number of bits. It's a number of characters, it's a very less, only 3. That's why it's very easy to create the tree as well as just find out the maximum 2 bits for encryption or something like alphabets ABC. Is there any query up to this one? Any doubt? Any query? Okay, only one Darshan is replying anyway. So yes, Darshan, what is the final number of bits for the variable length? In a fixed length, we got the answer. That's a 70, I think, in previous method. Yeah, but now here, what is the final answer? How many bits required to send? Guys, what is the answer here? Darshan, how many bits? Or is there any other students?
Sir, can you explain how to calculate bit? Once.
Okay, let's see. Okay, this is your table. That's a character frequency as well as Huffman coding. Okay. Now, see, for each and every character, that's a variable length. That means there is no fixed length. It may be variable, something like 2 bits for the one character, 3 bits for the another character, something like that one. Now, after creating this table, just simply send means count this frequency also. In your total message, in whole message, you are sending this letter capital F 4 times because it's a frequency 4. So that means You are just writing here capital A 4 times. So capital A, then that means how much bits? Sorry, how we can write in bits? So that's a 0 1. So that's why I am just writing here 4 into 2. That's for the capital A. Capital B 7 into 2. Capital C 3 into 3. Capital D this one 4 into 2. Sorry, 3 into 2. Here it should be, yeah, 3 into 2 and 4 into 2. Or let write this way also. For example, this is our complete message. Now here just writing capital A, that's a 1 0. B 0 only. C, that's a 1 1. Again B 0, again B. So this 5 character our complete. Similarly, you write this complete message and just count the number of bits. It's just obviously similar to 6 into 2. That's here answer 12. Here 8 into 1 bits because B के लिए एक ही bits है, so final 8. Here 6 into 2, so again it's a 12. So finally you will send the, I mean, it's a 12 plus 12, 24 plus 8, 32 bits for the message. 32 bits for the message. Similar in this example here, it's a 45. Done? Now one more thing here. We also have to send this one table also. That means ABC कैरेक्टर एज वेल एज उसके रिस्पेक्टिव ये जो भी कोड है वो भी हमें सेंड करना होगा. अदरवाइज रिसीवर को पता कैसे चलेगा कि यहाँ पे सर 0 मीन्स कैपिटल बी है, 1 0 दैट मीन्स कैपिटल ए है. हाउ डिकोड? सो फॉर द डिकोड we have to send table also. So in that table we are sending this one only. So just simply count this total bits. That's we may say that here it's 5 bits प्लस मुझे ये 3 लेटर भी सेंड करना है एबीसी, बट वो तो एक्चुअल लेटर सेंड करना है कैरेक्टर विदाउट एनी इंक्रिप्शन, क्योंकि वो तो मुझे नॉर्मली सेंड करना ही होगा. सो दैट्स अ 3 कैरेक्टर इनटू 8 बिट्स, क्योंकि हर एक कैरेक्टर के लिए हमें पता है कि 1 बाइट होता है. 1 बाइट दैट मीन्स 8 बिट्स. सो लेट्स टोटल फॉर दिस 24 plus 5 29 बिट्स फॉर द टेबल. ठीक है, और ऊपर कितना आ रहा था 32. So that's your final answer. Total is equal to 32 plus 29 bits. 32 that's for the message and 29 that's for the table. So total something like here it's a 61 bits. Yes, so this is the final answer for the variable length. While in the fixed length you got the answer 70. और अगर हम उसे हफमैन कोड में कुछ भी इंक्रिप्शन ना करें, नॉर्मल मैसेज की तरह सेंड करें, सो 20 कैरेक्टर्स इनटू 8, तो 160 लग रहे थे. 160 बिट हमें सेंड करने होते थे. उसकी जगह पे अगर हम फिक्स लेंथ यूज करें तो 70 बिट्स और वेरिएबल लेंथ यूज करें तो 61 बिट्स. सो इट डिपेंड्स ऑन नंबर ऑफ कैरेक्टर्स इन योर मैसेज. इफ इट इज लेस नंबर ऑफ कैरेक्टर, लेस नंबर ऑफ बिट्स रिक्वायर्ड टू सेंड. Now any query, any doubt? All of you clear? एग्जाम में एक एग्जाम्पल तो आएगा ही, हफमैन कोडिंग विथ वेरिएबल लेंथ. ओके, लास्ट वन मोर एग्जाम्पल विथ 5 कैरेक्टर्स. ये छोटा सा एग्जाम्पल था, बट नाउ वन मोर एग्जाम्पल. एंड दिस इज द लास्ट एग्जाम्पल फॉर द हफमैन कोडिंग. Just count. Okay, one more thing I'm just changing here. Okay, now just count for both the means fixed length as well as variable length. 5 plus 5, 10, 15 and 20. Okay. Now guys, try to solve this example and I want the answer from all the students. So fixed length, first of all, just simply count the how many bits require. Okay, Darshan, 115. Okay, might be correct. Let's see. So 5 characters, that means we require 3 bits, something like this one. This one. Then count the length. So 3 into 20, that's a 60 bits for the message, plus this table. So 3 into 5, that's a 15 bits, plus 5 into 8. Total 115, that's fine, correct. That's for the fixed length. Now try to implement for the means try to find out the variable. Sorry. So variable length, first of all, just simply create the table, that's the character and frequency. Then create the tree and find out the encryption code. Then send the data. What is the answer for the variable length? Anyone? Okay, that's an what's the answer here? Anyone? Anyone? What is the answer? How means table is created with frequency and encryption. Okay, anyway, I'm just writing the answer here. Okay, now variable length. So let's make the here frequency, character and Huffman code. How many times A? Frequency 1, 2, 3, 4. Okay. B, that's a 1, 2 and 3 only. C, 1, 2, 3, 3 plus 3, 6. D, that's a 1, 2, 3 and 4. And E, that's a frequency 1, 2, 3. Let's just simply make the, here it's a 20. Yes, 20. Now make the tree. So first I arrange in increasing order, or we may say it's ascending order, and make the tree. So first you are writing this one B, E, then A, D and C. Okay. When you combine B and E, something like this, give the name, that's a capital X. So after again arranging in ascending order, something like here capital X, where capital X is equal to B and E. Okay, that's 6 because of 3 plus 3. Now 4 plus 4. So you will get this one something Y, where capital Y is equal to and D. You have to just simply draw the tree, but I'm writing the answer without drawing the tree. That's why I'm writing this way. Now 6 plus 6, so you will get something like 12, and after arranging this one, my Z is equal to C and X, and finally you will get something like here final whatever get I node. So let's I'm just writing here tree, that's giving the name I, then here it's a Y, Z, Y, that means A and D, A, D, Z, that means C, X, and at last. So is it correct or not? Over here it's X and C. So finally you will get the answer, that's X, that means B and E. Okay, and just simply write the table, that's your 0 for the left child and 1 for the right child. So I'm just writing So starting from this one, suppose you want to write the A, so that's a 0 0 because 0 for the left child. B, so 1 1 0 1 1 0. I'm just here assuming here it's a tree. So here it's a right child 1, again right child 1, and then left child. That's why 1 1 0. Similarly, sorry, C, C that's 1 0. D 0 1, and E, that's a triple 1. Now just simply count the number of bits. So total bits is equal to 20, or you may just simply here count it's this one, 4 into 2 8, 8 plus 9, 3 into 3, then 12, again 8, then 3 plus 3 9. That's total bit, or you may say that's message. Now you have to send table also. So table 5 into 8, that's alphabets, and bits 2 plus 3 5, 5 plus 2 7 plus 2 9, 9 plus 3 12. So this is the final answer. Just make the summation. So here what is the answer? 9 plus 9 18, 18 plus 12 30, 30 plus 46 plus 40 plus 12. This is the answer from my side. So might be it's correct or wrong. Any doubt? Whatever it may be, any answer, something like 86 plus 12, or it may be something 98. So this is the number of bits for the variable length. And what's the answer for the fixed length? That's a 115. And if you will send the differently without any Huffman coding, then it's required the 180. Sorry, 20 into 8, 160. Yeah, so this is the answer. Any query in Huffman coding method, any doubt, then you may ask me. Otherwise, I want to close this topic here. In the next lecture, we will continue that with Dijkstra algorithm. That's for the graph. In that graph, we have also discussed the Prim algorithm and Kruskal minimum spanning tree. Minimum spanning tree that already we have discussed. So we will, in the next lecture, we will just simply over with the minimum spanning tree, Prim and Kruskal, and then move to the Dijkstra algorithm. So today up to this one. Now I want to take the attendance. Sorry. Okay. Ayush, Manav, Anuj.
Yes, sir.
Manav. Manav is present. Riddhi, Vidhi, just. Mansi, Nikita, Rohan. Bipin, Manthan, Mohammed.
Present, sir.
Okay, Bipin, Manthan, both are present. So now, is there any other students in big data? Okay. Sorry. Now AI branch. Anyone present in number 1 to 10?
Yes,
Smith, Devans, Divyajit, Tushar, Yasang, Divyajit. Okay, wait. Divyajit, Yash Thakur, Yasang, present. Darshan Parmar, 1 to 10 only, or just wait. Darshan Parmar, then Dipen, okay. After Dipen, Darshan Maniyar, okay. So random number 1 and 2 are absent, Smith and Devans. Rest of the 3, 4, 5, 6, 7, 8, 10 present. These are present, okay. Now 11 to 20. Yeah, enrollment number 11 to 20. So that's 18 present. Deep 20 present. Now 21 to 30. 24 present. 22, 23. Okay, both are present. 31 to 40. 35 Kunal, 34 Muhammad, then 40 years. Okay. 41 to 50. 41 to 50. Anyone? 49, 47, 48. That means 47, 48, 49. 51 to 60. 51 to 60. 51, 56. 51, 55, 56. Okay. 61 to 70. 69 to 68. 68, 69. Then 71 onwards, D to D.
73.
71. Then 73, okay,
73.
all day. Yeah. Then D to D5, Kunal. Okay. Is there any other students? Okay, Pema present. Girish, what's your number? 58. Okay, present. Okay, guys, you may leave.